Hi, I'm Dr. J.D. Eveland, and I'm here to talk a little bit about diagramming research models and creating the kind of tools that we can use to do various kinds of research. So I hope you'll have a chance to run through this and get a sense of what kind of value we can derive by being careful about the kind of models that we want to investigate. Before we begin, let's talk a little bit about what research really is. All research is the systematic investigation of things around us. When I say systematic, I mean there are various kinds of rules that we adopt for helping us determine whether or not we really know the things we think we know. There are a whole lot of ways we can go wrong, but that's what we develop these rules to protect us against. Basically, what we're trying to do is to extend our control over the world around us, and the long-term interest is simply protecting ourselves from the world. It's important to know that there is, as I say, power in naming things. Research discovers new things, and by the time you can identify and isolate out new phenomena, you have contributed to the overall growth of the body of knowledge. But it is important to remember at the same time that all of our research is limited to various kinds of populations and various kinds of relations, and the kind of research that we typically do does not allow us to extend our power too far. It is important, therefore, to understand the limitations on each kind of research that we undertake. This is the real world. In the real world, there are lots of things going on, lots of elements, lots of different kinds of connections among them, different kinds of relationships. It's this kind of blooming, buzzing confusion that we term the world and all of the elements in it. In this world, everything is connected to everything else in various ways and forms, and isolating out particular relationships for examination is very difficult. So the world is far more complicated than we ever can begin to comprehend and work with, but we do the best we can with it. But this is the context within which we have to undertake all of the kind of work that we do in the research area. A research model is a statement about the kind of specific relationships and elements we want to examine. We abstract these out of the real world by the nature of the theories we adopt, and we form statements about these relationships between these abstract entities. We then turn to defining the data that we can include and exclude according to the nature of the model. The model tells us what kind of things we want to pay attention to and what kinds of things we don't want to pay attention to. The explicit hypotheses we offer form inferences about causality and the efficacy of different kinds of connections. We are hoping to be able to affect these relationships in one way or another. A model is very good for raising our assumptions and making it clear to us what we're paying attention to and what we're not paying attention to. It can also be very helpful in organizing the nature of the literature we look into behind us. Remember, it's important, models are never true or false. They are just more or less useful for certain kinds of purposes, and we're trying to figure out the circumstances under which the model may be appropriate or inappropriate. What we're trying to do is avoid being taken in by our models. We don't want to believe them. We just want to be sure that we understand what we're dealing with and what we can do to use them with. Here's an example of a model that we've taken out of this real world of buzzing confusion that we noticed earlier. In this world, we've paid attention to certain kinds of things and certain kinds of relationships, and we suggest that certain things have effects on other things. But this is obviously out of the context of the much larger world of phenomena in general. In this particular case, the model suggests that public happiness can increase or decrease. If it goes down, then it tends to result in stricter laws being produced, which in turn results in more police, a decrease in street predation, hopefully a decrease in the death rate, but it also may lead to the emergence of a kind of rogue cops who may be going after after things for themselves, the so-called Dirty Harry phenomenon. But it also suggests that as public happiness goes up, public confidence goes up, that the death rate goes down, may result in the election of certain law and order candidates, and there's an implicit body of connection among these things. But it all has to remember we're taking place within the context of this much larger world around us that is totally uncontrollable. So by forming this kind of a model, we can identify certain kinds of things we can look at, but we also understand all the kinds of things that we can't look at as we're proceeding. Years ago, I formulated what I call Eveland's first law of data, and you can see it here. Treat your data as you would like to be treated if you were a datum. This has implications for lots of things. It implies, among other things, that the data really are in a form of living things. Since they are in fact abstracted from the living things, they contain their properties, and these may be expressed in either numbers or words, but they are in fact representations of real living things. Therefore, they deserve the same kind of respect that you would show to other living things, and you want to be sure that you don't mistreat them, because they really would like to tell you the story. If you let them tell you a story, they will be very good to you. If you mistreat them, you could tell any story you want to tell, but they will not actually produce results you can use. So respect your data and understand that your data are the things that you have to work with. And if you do that, you have a chance of being able to really understand the phenomena you're looking into.
Underlying most the notions of the theory that we talk about in the context of organizations is implicitly the notion of causality. That is, we are dealing with theory as a way of establishing a notion of causality, the notion that we do something that something else results. There are certain conditions that underlie the notion of causality, and these are sort of the part of the philosophy of science, if you will, but they are worth reviewing briefly here because it is important to note because this has a great deal to do with how we put the models together. The first notion, part of causality, is the notion of covariation. That is to say, the presumed cause and the presumed effect should vary simultaneously, and as one changes, the other should also change. It should be fairly obvious that the cause should precede the effect. That is, we don't want to have things that happen today caused by things that happen tomorrow. It's also important that we eliminate obvious joint causes, things that cause both simultaneously to occur. That's often known as spurious causality and is fairly easy usually to detect, although not always. The latter two are a little more controversial, but I will offer them for what they're worth here. And that for the fourth one is the notion that there must be some notion of how this cause might take place. This is a more strict requirement than one might always insist upon. Often one can't necessarily be able to trace what the causal mechanism might be, but it I would argue that it's really important that there at least be some notion of what it might be, even if it's not researchable or directly observable. If there's no possible way that one can see within the natural world why certain things should be related in a causal way, then one could argue it's very difficult to form a meaningful notion of causality there. And the final one is a much more judgmental kind of criterion, and that is the question of how many cases do you insist upon before you accept that there's a causal relationship involved. Not all causal relationships are deterministic or 100% effective. Some are probabilistic in varying degrees. In general, it's probably not terribly helpful to speak of causality in cases where there are relatively few cases where this takes place, probably at least less than 50%. Generally, the more cases that are related in the appropriate fashion, the higher the level of causality we'd assert. But I think it's appropriate to think about these notions in terms of why we might be interested in the notion of causality. A few words that are worth maintaining when we get into the discussion down the road a little bit here, and that is the distinction between concepts and variables is important. The concepts are the more abstract definitions of the terms. They are the classes of behavioral or observable phenomena that we deal with. and they are necessarily defined at a fairly abstract level. The variables, on the other hand, are those concepts translated into operations or measurements. When we speak of a variable, we are implicitly talking about something that we can, in fact, measure, and that presumably does vary. So we want to be sure we have that distinction in mind. Theory discussions are typically formed in the notion, in the relationship of concepts. When we begin to talk about variables, we begin to talk about theory in terms of models, and we'll discuss this again in a few moments down the road. There are a class of things called statements, and these include the basic axioms, which are the essentially non-debatable facts of the situation, or the facts of nature that we have to cope with. Then we speak frequently of postulates, propositions, and hypotheses. Postulates being the assumptions, the things we start with as givens. They are capable of being adjusted and modified, and often produce different results depending on what you do, but they are basically where you start. Propositions are statements about relationships between concepts, and hypotheses are statements about relationships between variables. That's a fairly straightforward definition. We will talk about, when we talk about research questions, we're often talking about variations on propositions. Research questions are typically stated in terms of concepts rather than variables to be most interesting. It is important to remember when we talk about hypotheses, as we will a little bit later on, that we are always talking about a statement, a declarative statement about a relationship among variables. That's what constitutes a hypothesis, and that's what makes one well-formed, well-defined. But these are basic terms that are helpful to know as we proceed through the rest of the discussion. When we talk about what constitutes a well-formed hypothesis, we're talking about relatively few criteria, but very important ones. First of all, a hypothesis does have the quality of prediction. That is, it is a statement about that something will happen as a result of something else. If A, then B. Hypotheses are implicitly declarative. They are affirmative statements. They may talk about negative relationships, but they are always affirmative in this form. They are not questions. They are not tentative statements. They are assertions about the world. As I've said on various occasions, no one ever went to jail for failing to confirm an hypothesis. It is not. They are stated as things to be investigated, and one should avoid the degree of intellectual or personal attachment to a hypothesis that requires some form of atonement if the hypothesis is not fulfilled. Hypotheses are tentative statements always and should be treated as such. It is important to remember that. Hypotheses are about a small number of things. A hypothesis can't fold too many kinds of constructs or variables into itself and still remain well formed. And finally, there must be some implicit notion of some degree of testing that could be carried out to speak of a meaningful hypothesis. We can talk about various kinds of more generalized propositions that one could investigate in more qualitative studies, for example, but it is very difficult to speak of a hypothesis in that context. The important notion of a hypothesis is that it is something that is testable by methodologies that are well accepted. We have not talked yet. We will talk later about the notion of what constitutes statistically testable and why that's of use and helpful. We'll talk about that some down the road. But for now, simply accept that a hypothesis does need some form of confirmation. The general idea of a model is kind of very important to what we're trying to get at in this class and indeed with the rest of the program. The model is the theory translated into specifics. It is the particular instance of the theory applied to the research that you're going to be doing. It is a critical intersection of theory and methodology. This is a diagram that one of my students some years ago came up with, and I think it's really quite good. I rendered it in slightly simpler form. The notion here is that, based on the entire literature base on which everything eventually rests, there is a conceptual foundation which consists of certain key constructs and ideas and relationships. The model is built upon that. That is folded within the notion of a theoretical framework, and that in turn is folded within the notion of an analytical framework. We toss around a lot of language in this area, but it's really important to try to remember what some of these terms mean. I think this is a useful way of sorting out the kind of hierarchy of constructs that are involved in this sort of notion, and need to pay attention to what we're getting at here. You've all seen this diagram before as well. It's fairly common. It is basically the notion that theory maps onto experience in various kinds of ways, and when we're working at the level of theory, we're working with various kinds of more abstract constructs and more abstract notions of causality than we can deal with at the real world level. But it is the notion of that mapping that makes it possible for us to speak of testing theories and speak of being able to confirm or disconfirm theory predictions in the real world. That's what this whole notion is all about, of trying to get these two things to work together, and that's where the notion of being able to specify your theory clearly becomes important, because it's on the basis of that you then can go on to specify the nature of your study and the nature of the data that you actually can gather and why it relates to the theory as it stands. Now we're getting down to the core of what this process is all about, and that is sort of the how to do it phase of the process. Essentially, it's really quite simple. There are two categories of things being represented. One is the notion of the variables involved, and the second is the notion of the relationships. In general, boxes are used to represent variables, and arrows and lines are used to represent relationships. There are some variations on this for certain other kinds of models, but for the time being, we'll let this stand for what we're trying to get at here. When we're developing these kinds of models, we're basically looking at trying to put into the model only those things that are really worth paying attention to. And it's certainly quite clear that not every relationship in every possible connection among the variables in our framework might be interesting to investigate. In this case, we have a limited number of variables and a limited number of relationships being tested. We want to notice that it's appropriate sometimes to note that certain relationships exist but are not part of the model itself, and that's the kind of correlational relationships that often exist among a series of predictors. In this particular case, for motive variables, all of which are represented as being correlated with one another, although that's not part of the theory itself. In general, anything not included on the chart or included in the form of curved lines is not considered to be part of the model itself. In general, the causality notion is seen as going from left to right. That is, on the far right are the prior variables, the primary variables, and the ultimate outcomes lie on the far right-hand side of the page. It is appropriate and usually helpful in a representation of a model to identify the nature of the directionality of the relationships. We've said earlier that hypotheses need to be directional. They need to speak of what direction, how the two variables change relative to each other, and they can change in either one of two directions. They can either be directly related, or sometimes called positively related. That is, as one changes in one direction, the other changes in the same direction. Or they can be negatively or inversely related. That is, as one increases, for example, the other decreases. These are the only two choices you really have in the nature of the kind of relationships we're dealing with here. And it is usually considered very helpful to represent these on the model chart as a way of figuring out what you're trying to get at. We often speak of two further categories of variables to be included in the model, and these are mediator variables and moderator variables. This is a fine distinction, but it is a meaningful one, and one that's useful to maintain, and I suggest that you really pay some attention to it when you create your own models. The notion is fairly distinctive if you stop to think about it. A mediator variable is a variable that is part of the model itself. It intervenes between variables that are currently in the model itself, the more important ones, and it usually it provides some explanatory power in its own fashion. It's not a primary focus for the theory, but it is a meaningful contributor to it. A moderator variable, on the other hand, is usually a variable that's thrown in more for analytical purposes at the end, as a way of using up some of the spare variance so that a greater chance of finding confirmed hypotheses could take place. These are either qualitative or quantitative, and they can be treated in either various statistical ways depending on that. But they are, in general ways, things that affect the nature of the relationship or attenuate or increase the strength of a relationship between the variables that are technically part of the model. They are basically often demographic factors or other things of that sort, and this is a good way to use demographic variables in this fashion. since they're seldom the subject of much theory that's mostly interesting in their own right. The distinction is worth maintaining because they are treated differently for analytical purposes, and it's worthwhile maintaining that distinction. I suggest you pay some attention to it and think about it in relationship to your own studies. Here's an example. We'll sort of wrap up here with this. If we have a proposition to begin with, and that is the simple proposition that pizza gives you heartburn. This happens for some people. It may or may not for you, but let's assume that for the moment that it does. We can form some hypotheses related to this within this construct. And one hypothesis that makes a certain amount of sense is that the more pizza you eat, the more heartburn you experience. This is a simple positive relationship, and this is how you would diagram it. The diagram indicates the two variables that are involved, the nature of the relationship, which is a direct relationship, and it's quite clear which one is considered to be the predictor and which one is considered to be the criterion or outcome variable. This is the simplest possible form of a model, but it leads to one easily expressible hypothesis. Adding a slightly more complicated factor to this, let's add a moderator variable. A moderator variable here might be, example, the time of the day at which we eat the pizza. Obviously, at certain times of day, we're going to have different reactions to things, and it's quite possible that the relationship here is actually a curvilinear one of the sort we've represented here. That is, that some times of day it's more severe and other times of day it's less severe. It is reasonable to form a hypothesis that says that the time of day does moderate the relationship here. It's not part of the theory per se, because we're still interested in the relationship between pizza and heartburn, but we are interested in improving our prediction, and if we know that at certain hours we're going to have more heartburn than others per amount of pizza eaten, then we can factor that in. It becomes a useful addition to the model. A third hypothesis that we could add has to do with a mediating relationship, and this will give you a chance to see how this differs from the moderating relationship. The mediator here is beer consumption. That is, the more beer you drink, the more heartburn you're likely to experience, and the more pizza you eat, the more beer you drink. This is a variable that, as you see, falls in between the two, and so part of the heartburn is created by the pizza and part is created by the beer, and the beer in turn is created by the pizza. So the notion of the mediator here is that that part of the effect of the pizza is felt directly on the heartburn, and part of it is felt as mediated variable through beer. If you stop to think about these, they're fairly simple kinds of approaches, but they do illustrate fairly clearly what the difference is, and I think you can see how they both factor in. We have here three simple little models, three simple hypotheses, and they lend themselves to fairly easy analysis and testing. Just to finish up, I want to show you an example of in this particular case, the model that he has chosen to investigate here has to do with the